With this example, we're looking at division of rational expressions, and just like with fractions, a division problem can always be rewritten as multiplication by the reciprocal. And that's exactly what we want to do in this case, is the first fraction doesn't change at all, but then the second one becomes multiplication by the reciprocal. And remember that reciprocal basically just means flip the fraction. So that's how we're going to start this one off, and then once we do that, it's just a factoring game again. So as far as our upper left, that doesn't factor, so it's just a factor of x plus 2. Similarly, the lower left is just x minus 2. The lower right, the x squared minus 4, that's a difference of squares, so that's just going to be our x plus 2, x minus 2. And then the upper right, we're looking for things that multiply to give us negative 2, but add to give us positive 1. So that's going to be negative 2, oh no, positive 2, and negative 1. And that should add together to equal positive 1, multiply to be negative 2. And once we have that, now we can do the whole matching thing. We've got an x plus 2 in the top and the bottom, so those divide out. We don't have an x minus 2 in the top and the bottom, and so that's as good as we can get. So up top, we've got an x plus 2 and an x minus 1. And in the bottom, we've got a couple x minus 2's. So we can either write it as x minus 2 times x minus 2, or we can write it as x minus 2 squared. Now, if you really wanted to, you could go ahead and FOIL out the top and end up with a trinomial. In the bottom, you could also multiply that out. It's not really necessary, though, so you may as well leave it in the factored form, because not only does it show you that it doesn't simplify any further, you're not going to make any mistakes as you try to multiply it out and end up getting a wrong answer because you made a mistake in extra steps. So you don't want to do that.